Thank you everyone for attending today's webinar, Olloclip Advances iPhone Camera Capabilities with 3D Printing, brought to you by Objet and Design World Magazine. We would like to thank our presenters, Chong Pak, Director of Design at Olloclip, and Susan York from Objet for being here today. I'm Leslie Langnaw, Managing Editor at Design World, and I'll be your moderator. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar anytime during or after, you can use the hashtag DWWebinar to tweet your comments. We will also have a Q&A session after the presentations, but you can go ahead and submit your questions at any time, and we will ask them when the presenters are finished. I'd like to introduce to you our two speakers. Chong Pak is the Director of Design at Olloclip, where he oversees the development of the product line from concept to manufacturing through a team of designers and engineers. He previously worked for design consultancy and as a freelancer for various clients ranging from the automotive industry to consumer products. His work for such companies as Mercedes-Benz has been featured on national commercials. Chong has also been avidly teaching design to aspiring designers who have then gone on to great achievements. He received his undergraduate degree from the Art Center College of Design and his MBA from Argosy University. Susan York is the new National Field Manager for the Consumables line of business at Objet. Her nearly 18 years of experience in this industry has included roles in engineering, R&D, applications development, and sales management. As one of the pioneering developers of rapid prototyping technology, she has written several white papers and technical guides. Her broad range of experience in this industry has made her a key contributor to the increasingly broad adoption of rapid prototyping technology throughout American industry. After almost a decade of highly successful sales and channel management, she is now moving into managing the consumables line of Objet's business for the United States. And without further ado, I'm going to hand over the mic to Chong.
Thank you, Leslie. At the risk of sounding repetitive, I do want to go through a brief introduction of myself. As Leslie mentioned, my name is Chong Pak. I'm the Director of Design here at Olloclip. I graduated from the Art Center College of Design in Pasadena many years ago, it seems like now. And as she mentioned, I've done quite a few projects in the past with several clients, including Steelcase, Hahn, Johnson Controls. And it's been quite an experience working with those clients. And now I am working as the Director of Design here at Olloclip since its inception, which has been about over almost 2 years now. We're still a very young company, but you know, we have very high hopes in being here in the marketplace for a while. So, just to start, Olloclip, what is it? It's a 3-in-1 lens system for the iPhone 5, the 4S, and the 4. And as you can see in the photos, it's a really straightforward product, and that's what we really are pretty proud of. The lenses for this product include a fisheye, a wide angle, and a macro. And switching between the lenses involves simply flipping the Olloclip to the other side. It's, in our opinion, by far one of the most straightforward, simple solutions to what seems to be a growing a product category in the last few years. And we can shamelessly say that we're proud to say that we are voted the best photo lens accessory by Wired magazine last year. So a little history about our company. Was started and invented by my partner Patrick O'Neill. Let's see, the product was in development over a year before we launched on Kickstarter. Now, I'm not too sure if many people here are familiar with Kickstarter, but it's a crowdsourcing product development website. It's definitely garnered a lot more attention and a lot more publicity in the last few years with a lot of more high-profile projects coming along there. We took advantage of Kickstarter when it was a little bit lesser known, but fortunately we hit our funding goal and we actually surpassed it fairly well. And at that time, I believe we were one of the more successful projects to have been featured on that website. During the development process, we were using 3D printing very much from the get-go. Once we and I'll talk about the process in a little bit, but definitely from the get-go, we knew that to have this product ready as quickly as possible, that we would need to utilize 3D printing to get the results in the time frame that we wanted. Let's see. Oh, yeah. So as I mentioned, we were successfully funded, well above what we asked for, and on top of which, we definitely saw Kickstarter as a way of getting our name out there and getting exposure, not just domestically, but literally all over the world. A little bit more of the history. For many months, we were a very small team consisting of Patrick and I, along with his family and friends, assembling and fulfilling orders for the first few months. We were definitely one of those stories where our first order fulfillment to Apple was actually fulfilled from his garage. So I think there's that kind of fun little aspect of the fact that we really were literally one of those garage businesses that hopefully will continue to be a success story. We've grown enough to have moved twice consecutively to consecutively larger offices in less than 2 years. So we are definitely experiencing a success that we're pretty proud of. We have a small agile team of designers and engineers. As you can see on the slide in the top photo, that's our current office space right now. A lot of interesting stuff going on currently, but we are still a small organization, and really we have a small team, but I think there's definitely a benefit to that currently. In the lower picture, you can see our object machine in the office. Rapid prototyping was and is still extensively used in our process. And I'll get to that a bit more in depthly in a second, but it's definitely a machine that we use on a regular basis. Now, prior to having the machine in our own office, we were actually outsourcing printing to a service bureau, which in of itself is not a bad thing. And through that process, we were still able to get parts delivered and do validation on our concepts on a quickly turnaround time basis. But as we just really wanted to get more control and more of a quicker turnaround, it led us to basically want to have a printer in-house for time savings, and as you can see, we mentioned IP protection. That was definitely something we felt that was key to making sure that we continue to have our advantage that we have, so that we kept all files and information in-house as much as possible. So over time, through this experience, we felt that having our own printer was going to be beneficial. So how does the 3D printing process really kind of play in our organization? This is a quick overview of generally kind of an ideal process in which we develop new products, if not improve upon the products that we currently have. First and foremost, it comes with brainstorming, concept generation. I think actually prior to that, it would really be to determine what we want to design. And then once we determine what the project and what our design needs are, then we start doing the brainstorming and the concept generation phase. After that, our designers begin sketching their ideas, and we'll have a review of those said ideas, and afterwards we'll choose the ones that we feel are the most successful, if not that have the most promise, and we'll take those, and then we'll have our CAD engineers model those concepts into the computer. And once that's done and all the fine tuning is for the respective phase that we're in, if the fine tuning is done, then we can actually send that file immediately to the printer, all done within our own office. And then once the printer is finished, we can then take our part and evaluate the prototype for whatever criteria that we need. Generally, it's functionality, proportions, even aesthetics. Do we like any given aesthetic element that we've chosen to implement for this particular design? You can see in the photos at the bottom that one of our designers there is using the 3D prototype right there as an analysis tool. And the beauty of it is that this process, depending on how complicated the product is or how complicated anything at any point is, this can literally be done within a workday. If the sketch is done within the morning, and it went well, we could have our guy model it in the afternoon, and we can send it to the printer with printer next to us at the end of the day, and we leave, and by the morning it'll be ready for us to take out of the printer and evaluate. So in this definite product category where phones are ever changing and people are expecting products to come out almost instantaneously after a new model is announced, hopefully you guys can see as well as we've pretty much seen that there is an advantage to being very quick to have prototypes and products to hold in your hand and to evaluate. And so we have the opportunity to have these things occur in such a quick turnaround time that it's been quite amazing, quite honestly. And just finishing up the slide here, once we evaluate the prototype and we realize that some changes need to be made, we will make those changes, and then we can reprint it and then reevaluate and so on and so forth. So we can repeat the process as long as we need, so that we can continue to polish and refine whatever concepts that we're working on. And number 8, if the concept is approved and everything looks good, then we can then send the model and whatnot into, and work with our partners in terms of getting it mass produced. So let's see. So this is a photo of an example of how we use the printer. On the left is a naked prototype that we printed off our Objet machine. Versus what you can see in the production version, very similar. The results have been pretty good in regards to we can get a really good sense of what the final product will be like using these printers. And then just to give you a sense of how we use the printers to validate and evaluate our products, specifically in this case for the Olloclip, you can see that we actually are able to do somewhat of a manufacturing approach to, even with the prototypes, to put in the lenses, and then we can actually put them on the phone and examine fit, finish, and whatnot, and then final product on the right. So this is kind of like an encompassing photo of how we use in many ways the printer that we have. So why Objet? I can tell you that I was definitely one of the people given the responsibility of choosing the printer, and it took us quite a bit of time because we really wanted to make sure that we chose the right printer for our needs. There are many great printers out there and many great different ways of doing it, but we needed one that was best for our use and our needs. Excuse me. So we, in the end, decided to go with Objet. And in the bullet points on the left, I listed probably the main 4 reasons that we went with that. One of them being the resolution of the printed parts. We thought the resolution, given the sheer size that we work with on our products, they're not large. They're very small in scale, as you can imagine. We wanted a printer that had the resolution to deal with the details and the finer the finer things that certain other printers would have difficulty with. The other thing was the robustness of the parts to function as we needed them to. Meaning, for a good example, is we actually had a different printing process to evaluate, and when we inserted the lens, the prototype would actually crack or break, and it would occur too often in that particular process. So we determined that that was not a direction we wanted to go, and the object machine itself held up to the stresses of the assembly process that we needed them to. So that was definitely a plus on their side. The ability to print multiple materials. Now, I know the particular version that we have here in our office does not print simultaneously, um, but the option of at least changing it out and still being able to use a different material if we had to, rather than being purely stuck with one material at any given time, was also kind of future-proofing our desire to use this machine in ways we may not have determined at the initial time of purchase. And finally, given that we're still a small business and many other things are done um, by us in regards to just taking out the trash, whatnot, material handling and disposal was definitely key. We didn't want to have a large vat of unenclosed resin just sitting in the office or whatnot. This machine definitely seemed to be a good compromise between ease of handling at the same time, the versatility that we needed for the materials to function. So all in all, just going through the checklist in regards to all those things, we determined that the object was by far the best for our purposes. So how do we here at Olloclip envision using 3D printing in the next few years? And I actually I actually took a scene. I don't know how many of you guys are familiar with the movie The Fifth Element, and that came out many years ago with Bruce Willis. There's a scene in there that actually they're able to replicate a living being in this vat or in this chamber. And the minute I was asked to talk about the future of prototyping and 3D printing, this scene immediately came to mind, because I wouldn't totally be surprised if in the next however many years that we would be able to get to a level that we can do such a thing where you're able to almost replicate a person simply with a few pieces of information. But um, we we've known as a company, and we live, I mean, not we live, but we started in an era where 3D printing was regularly available to us. So I can't vouch, although I am familiar with the process prior to 3D printing, of having to get a model maker and delay the process or wait for the model maker to make a prototype, and then that would take weeks, and then you'd have to evaluate it, and then you'd have to have the model maker then go back and take however many more weeks to hand fabricate and build by hand a prototype. We're definitely fortunate to have a business that exists in a time where 3D printing is so easily accessible to us. But we knew that I think our product wouldn't have been as competitive and as successful in terms of getting it to market without using it from the get-go. And I don't, it's one of those things where I can't foresee us going backwards and using it less. I know, speaking with Patrick, that we're just excited to see what the future of 3D printing will give us in terms of the ability to just really bridge that gap between development and production, in terms of just making it more and more a part of the process in which we develop our products. It's one of those where I can't foresee it, because I'm waiting for uh, Objet to come out with this one, with the new machine that'll do, 20 other things that will eliminate maybe a certain development obstacle that we have now. So 3D printing and Olloclip are definitely going to be together for a long time, if not just forever, because it's become such an integral part of our design process and how we can get our products to market as quickly as possible. So it's a key tool in our arsenal, and we don't foresee it ever going away. If not, we will definitely use it more and more as it gets more sophisticated. So that's my quick little presentation on who we are and how we use our 3D printers, and that's it. Thank you.
Thank you, Chong, for the presentation. That was very interesting. And now we're going to have Susan come and give her presentation.
Thank you, Chong. I liked your vision for the future and your explanation as to where your product is currently at. So today I'd like to share with you how Objet material development has evolved with a primary focus on assisting our customers in their rapid prototyping needs for product lifecycle development, such as this iPhone professional camera lens. I will be reviewing a story of who Objet is, talk about our unique material offerings, and how we compare to standard production plastics. So Objet is a leading provider of 3D printing solutions. This is a solution of systems, resins, and applications. At Objet, we focus our core competencies on strengthening our capabilities in rapid prototyping specifically. While the industry has evolved into rapid manufacturing and short-run production, our technology lends itself to all of that. However, our primary focus over the years is to provide a solution for the overall scope of rapid prototyping needs. Now, while Objet has been privately held, I will share with you that we have thousands of customers worldwide, with a large share of the customers ranking in the Fortune 500 circle. We're the fastest growing 3D printer manufacturing and started up in 1998 and began commercial deliveries in late 2001. We achieved over $100 million in sales in 2010 and have enjoyed double-digit organic revenue growth over the last 7 years, which is pretty phenomenal considering the economic downturn at one point. We have strong presence throughout the world with offices in the United States, Europe, Japan, China, Hong Kong, and India, and even more of a presence through our large network and distribution partners. And among all the rapid prototyping companies, Objet invests more of its R&D annually than any other company in the industry. We are an innovative company with over 110 patents, and many of which belong to materials, which I will be speaking more about as the presentation goes along. So what makes us stand apart? What's unique from the inception is Objet has leveraged its success around the multi-billion-dollar inkjet technology found in any home office paper printer. This inkjet technology allows us to create parts that provide fine detail due to the resolution and great speed and efficiency. And it's scalable, meaning that regardless of which Objet system is used, you're going to achieve the exact same results of surface finish, details, and speed. So it's because of the growth in production plastics that Objet is focused on providing a host of solutions for plastics rapid prototyping, which is essentially the simulation of real-world plastics, specifically made from plastics, not metal or wood. From static to dynamic parts with a multitude of applications, our unique technology offers abundant solutions. Now, let's move into the real world of products. A great deal of products today are made from plastics. Think about products from phones to automobiles to household consumer products. A number of these products that we use daily are made from plastics in some way, shape, or form. The cost performance pyramid that you see here provides the different levels of plastics, from standard plastics to engineering, the high performance plastics, and the majority of production plastics are represented on this chart. You can see that ABS is circled off to the side, which lays just on the border between standard and engineering grade plastics. Cost-wise, ABS is in the category of standard plastics, but its properties are just into the engineering grade plastics. As you go higher onto the pyramid, you can see that the materials become improved by enhanced properties. Oftentimes, this is most determined by the application. As you keep going up the pyramid, the plastics will offer greater strength, moisture resistance, and toughness, which is resistance to breakage, all of which are desirable, again, depending on the application. So in a way, the pyramid is a roadmap for our chemists to develop more advanced materials. We would like our materials to continue to better and more closely simulate the exact characteristics of standard engineering plastics, and hopefully someday move up into the higher performance plastics that you see here. A little bit of a delay here switching. So the essentials of the rapid prototyping is the successful simulation of final production fit, form, and function. With our inkjet technology, we have the ability to build in 16-micron layers, which lends itself to a more accurate fit of assembly parts and smooth surface finish for the form. But functionally, it's a direct correlation of the properties of the materials used. For instance, if a part will be rotated with higher IPMs, or if a part will need to withstand a high temperature environment. How the part behaves in the testing environment is directly attributable to the material properties and characteristics. That is where our development efforts are focused on providing more and more materials that are on the functional performance side. So I'd like to take you back 2 years ago to 2010 when Objet was deep into its standard plastic simulation. The materials in 2010 are denoted with the orange crosses on the chart, which are kind of in the middle there. One thing to denote on the graph is the fact that if Objet had a tough material like the bottom crosses, it can easily be seen that the temperature resistance is quite low. However, when Objet introduced VeroClear, which is at the top left orange cross, it has a better temperature resistance, but it's less tough. Now, that is a reflection of some of the polymeric chemistry, which deals with trade-offs. If you achieve toughness, you compromise the temperature resistance, and vice versa. This presents quite a challenge, but through time and perseverance, you will see later in my presentation how Objet has been able to overcome these challenges in the photopolymeric chemistry and succeeded in developing materials that are both tough and temperature resistant. So in continuing along where we were at in 2010 and simulating standard plastics, this picture demonstrates that Objet Technology jetting with single model material along with support material. For example, in this picture you can see the VeroClear blue and the support material jetting down to build up a part. And on the right-hand side demonstrates the UV light which is curing the part. And as each layer is deposited, the Z stage increments downward so that the next layer can be built. This process continues until the part is completed. Using the exact technology in 2010, we were very successful in using or providing 13 different modeling materials which offer rigid, flexible materials in different shore values and medical, transparent, and opaque materials. But it's still all about standard plastic simulation. Earlier in 2007, Objet continued to develop its technology and launched its multiple material capabilities available on the Connex platform. That's something that Chang alluded to in his presentation earlier. So we have different systems that can allow for multiple material capabilities. As you see here, there are two different materials being utilized, which are denoted in the material A and B. The first is a mixed part, and the second is a digital part, which is a composite material where A and B are combined together on the fly by the software. This is about the same materials that are composed to generate digital materials. Digital materials do not exist in a cartridge, but are achieved through software, which creates a composite on the fly. But beyond the material composition, our technology precisely creates a structure in which to deposit the material onto the build platform, which in turn makes up the part itself. So it was this technology breakthrough that enabled a unique achievement in creating multiple material builds and digital material compositions, which takes two cartridges based model material to create advanced material properties, which we were not able to achieve before through a single cartridge previously. And this is just giving you some up close of the different matrices of the materials combined together. So this slide shows a selection of parts from our digital materials back in 2010. While this is very impressive, it's still all about standard plastic simulation. Even the composition between rigid and rubber material, which was amazing at this time and captured a great amount of attention in applications of labeling, shock absorption, and overmolding, anatomical models, all of which are fantastic, but from a materials property standpoint, this was nothing more than standard plastic simulation. Now, in early 2011, Objet stated in a press release that we were going to launch materials that would have improved dimensional stability, improved temperature resistance, and toughness. We were striving to make significant advancements in enhancing our existing materials, but also launching new materials with improvements in both axes of temperature and toughness to strive to enhance our material characteristics closer to true ABS. This slide is pulling some data from the Wohlers report in 2012, which shows that 52% of the industry processes are fit and form. It also states that fit and form require dimensional stability and needs to be visually pleasing, which falls into the material color and surface finish. The percentage is about 2% lower from last year, giving way to rapid manufacturing. So in keeping with the growing demand for fit and form capabilities, Objet launched its VeroClear material this year in April 2011. We are now more than 1 year after the launch, and the material is successfully being used in various industries such as automotive, medical, cosmetic, consumer goods, and consumer electric, for example. The VeroClear material simulates PMMA, or referred to its trade name plexiglass. Chemically, VeroClear is a synthetic polymer of methyl methacrylate, and it's an economic alternative to polycarbonate when extreme strength is not necessary, and transmits about 92% of visibility given a 3 millimeter thickness of a part, and refracts about 1.4893 to 1.4899. So moving on to an example of a case study that highlights the successful application of creating colorless, transparent light guides and lenses during the developmental cycle of a new vehicle. So this just gives you a close-up of the actual light guide, and this is found on our website as well. Now back to the Wohlers report. We learned that about 38% have indicated in 2012 the importance of functional high temperature and high toughness in materials. And that's when Objet launched its RGD 525, which is our high temperature material solution. Our high temperature material provides higher temperature resistance directly out of the printer, and it's ideal for static parts testing. It provides the same smooth surface finish in post-processing such as plating. So moving into some of the examples of a variety of application stories, to the left is a nice story of a customer who manufactures sanitary devices. This customer uses VeroClear 720 for its first concept verification model, and would switch over to production materials when they went to use hot water. So at that time, the 720 model would not resist the temperature of the hot water. Now, at the time, with the release of the RGD 525 high temperature material, this new material allowed the customer to save time and money by conducting its testing with the hot water to forego the leap to final production materials. Now this customer can perform concept modeling, conduct true functional testing with hot water, and finalize the design before going forward with massive production tooling, all of which the new material, all with one new advanced material. So this is quite an achievement for them in their production and testing. Okay, so back to the axis of temperature resistance and toughness. With the high temperature material, both directly off the build and after post-curing process in a programmable oven, the material has allowed us to improve the temperature resistance, bring us even closer to our objective of true ABS material. But this again created another trade-off where the high temperature material is more brittle than VeroGray, and we were not able to change the toughness. So it gave us a new direction in working to get closer to true ABS. After focused development, we were able to achieve and release our green ABS property. So with the achievement of our ABS property, we were finally able to provide the first generation of true engineering plastic material. We're now able to achieve a thermal resistance of 149F right off the printer and 194F after thermal post-treatment in an oven. This material has also provided a higher impact strength resistance of more than 3 times that of our VeroClear family and 4 times that of the high temperature material. Here again are a variety of applications presented on the slide. The first is in automotive, where the parts were successfully performed in high temperature while outside. You can also see some bicycle parts that were metal parts that were tested with our ABS, and some parts on the bicycle had required a tight fit between the frame, which was made of carbon fiber, and metal parts that connect to the brake and the wheel shaft. In the past, whenever the tight fit was designed and the part was printed, it would break during the assembly, and they needed to compensate for it in CAD by increasing the space between the parts. Now they can use the original design in just a print of ABS, which saves them time. The overall frame part, which you see, is used for test and design, which with tires, brake system, and assemblies, to see that if it all fits and no mechanical interferences between the components. With this release of the ABS material, the bicycle manufacturer are the ability to shorten its developmental cycle and now testing the cycle by riding the bike with the ABS parts on it. As we turn to our access chart, you can see that the ABS material is no longer a showstopper when comparing ABS Objet offering to SLA. The Objet ABS-like material after thermal post-curing gets closer to the performance of FDM materials in terms of toughness and thermal resistance, while offering a great surface quality, accuracy, and fine details of Objet parts. But as mentioned earlier, the photopolymeric chemistry that always deals with trade-offs that are existing, you can see that SLA no longer faces the same challenges of brittleness. So that begs the question on exactly how we're able to successfully overcome this challenge. The difference is in how we're able to achieve this breakthrough was through our Connex technology. The ABS material is not a standalone material, but a digital material, which was made with a high temperature component and a high toughness component. And it's the software that composes them together to benefit from both worlds. Individually, these materials suffer from something. However, it's only in the composition of the two materials together that creates the benefits of this ABS material. This is a huge breakthrough for us in breaking a ceiling of achieving engineering plastics. This technology is the only one in the world with photopolymeric chemistry and enabled us this paradigm shift. Additional areas of development has been in the medical family of materials. Our hearing aid materials allows us for end parts for medical approvals, and the dental material solutions lends itself for stone models and orthodontic solutions. And finally, our new biocompatible material, the Med 610, which I'm going to go to next. This material has 5 medical approvals according to the harmonized standard ISO 10993-1, which is cytotoxicity, genotoxicity, delayed type hypersensitivity, irritation, and USP class 6. The combination of the biocompatible and colorless transparency makes this material ideal for medical and dental applications. So in closing, you can see that the material trajectory of the Objet materials, year over year, we release many new materials, and you can see that this year, we currently are at 107 materials total, 90 of which are digital composites. With each new release of base materials, this count of materials is only going to continue to climb, allowing us more and more advancements in our material offerings. And that's it for my presentation. Thank you.
If you have some questions, feel free to enter them in, and we will answer them and address them. One of the first questions that has come in, this one is for Chang. It's, can lenses be printed?
can lenses be printed? I believe the the short answer is no. Even though objet printers can print clear materials, it would require a lot of work in regards to getting that optics just right to get the desired results. So although clear material on the printer would be great for maybe just purely an aesthetic result, to really evaluate the optics, I don't believe, although I'm not the optics expert, I don't believe currently that it would be a very accurate way of evaluating optics.
Okay. And to continue on, Chong, when you first began working with this 3D printer, what were some of the features or the capabilities that surprised you, especially in regards to how it made things easier for you?
Um, that's a good question. What surprised us? Having had experience with 3D printing prior, I would really say the thing that kind of impressed me most was just the level of detail that we can get in with this printer. We really work with some fine details sometimes, and the reality is we push the limit, and there are times when the printer is not capable, quite frankly. But given that, I think the level of detail that we're able to accomplish and really get out of these printers have been really the biggest thing in regards to being pretty surprised.
Okay. And this question is going to be for Susan. So you're talking about the ABS-like materials. I'm kind of getting the impression there's a number of 3D printer manufacturers who claim ABS and ABS-like materials. So are there a lot of differences between how near to ABS they're like?
Well, there's 17,000 different grades of plastics out there. So it depends on where your material characteristics, what the goals are to achieve. So to answer your question, there are different ABS materials out there. However, this is the first time in as far as achieving smooth surface finish, high accuracy, and speed with the engineered plastics of ABS material.
Okay, thanks. We're going back to Chong and the lenses. This question came in. Objects showed clear lenses, but are they of ophthalmic quality or just generic translucence? That might be for you, Susan, too.
I'm sorry. So just to get a clarification of this question, um, are they asking about the lenses that were in my presentation?
I'm not sure. This person says, I guess this person has, no. Okay, they've encountered object clear lenses, but the question is, are they of ophthalmic quality or are they just generic translucents?
Okay, right. And I think that's kind of being more specific to the first question. The prototype that you saw in my presentation, in which you saw the various prototypes being lined up. The prototype with the lens included, actually that lens portion was not printed. That was actually added on later, and that was one of the main reasons we chose Objet, because the printed parts can sustain the type of stress that we require for it to kind of hold on to the lenses. So the translucent material, the clear material that the Objet prints would not be suitable for any optics evaluation, because there are just so many different characteristics in terms of, I would imagine, light refraction, you know, light refraction, and being able to really get the level of curvature, because I believe once you print the clear material, it still requires a bit of polishing and whatnot. So it's actually a very interesting question, to be quite honest, because I don't think I have a definitive answer, because we here haven't even considered printing clear material to see if it can be used to evaluate the optics. But I think that would also just require a level of finishing on that clear part that may or may not be worthwhile as opposed to just using existing optics, unless again it's going into just totally developing brand new proprietary optics. And even then, you know, the object and that material might have its limitations that prevent you from actually getting a true representation of what the optics would do. Hopefully that answered the question.
I have to agree with that.
Would you like to elaborate, Susan?
So I agree. I mean, it really speaks out to the level of optics in which you're trying to achieve. I think aesthetically, it is good for an initial visibility of lens representation. However, if you're going for optics testing, I would probably opt to go with the lenses itself. You can get a great level of detail and clarity in the part. So again, it depends on the curvature, it depends on the level that you're trying to gain in your optics. But you know, in final testing, I would definitely go with a standard lens.
Okay. A question has come in about what are the costs of resins, and they're just looking for ballpark figures, such as per cubic inch or per pound. Susan, would you like to address that?
Well, it really depends on which system you're looking at. So there's different canister sizes, but it really falls in line with the industry standard of ranges. So with the many different materials that we have, from flexible materials to you know, to ABS-like materials, we have a range, but it all falls within the industry standard, and it's something that we can elaborate on if they contact us directly.
Okay. I'm going to go back to Chang here a little bit. When you were looking at 3D printers in the market, what was the primary factor about the Objet that made you choose it over some of the other printers?
The biggest two criteria were, one, the level of detail and resolution that we needed. I think there were other printers that did other things, but you know, the resolution just quite wasn't there. And we work with tolerances that are pretty tight. And so we needed a printer that really would work with the tolerances that we needed. And secondly, we needed the material to be robust enough to handle the type of stresses that we would need to ask of it. And I think the Objet machine was just by far the best blend of both.
Okay. Susan, I noticed that Objet has recently released a couple more materials. So how many more materials does Objet offer now?
Well, we're always going to be expanding on our material selection, and historically we release anywhere from 1 to 3 new materials annually. So we are definitely in excess of 100 plus material combinations at this time.
Okay, a question has come in. What are the primary industries that Objet computer or printers are being used in?
Essentially every industry, any and every type of industry you can think of. Primarily, however, I'd say in the top tier is generally consumer goods, consumer electric, automotive, medical, dental. But in all honesty, it is any and every type of industry you can think of.
That's a strong list.
Yes.
Another question that has come in, and I'm curious about this one myself. Since the Stratasys and Objet merger has just been finalized, what can users expect in the near term?
Okay, that's kind of a general and vague question in and of itself.
So will there be new printers? Will there be will the two companies combine their systems? Will they operate as separate in a sense so that the product offerings kind of stay the same? Because I think the offerings are fairly complementary, but
yes, Stratasys and Objet have enjoyed a relationship in the past and now have come together as a complementary company. And to find out more information, I would like to guide you to a website that's been established. And the website is stratasys4a3dworld.com. And that will go through answering a lot of the general questions and provide some answers to the merger itself, as well as the product offering. So specifically as far as the product offering, you're going to see that the product lines are going to maintain their identity as far as the individual technologies, and we will continue to expand and grow upon our technology base, offering more of a product complementary family of systems to our customers. So it's just essentially increasing the family of technology that we have to offer, but you're going to see a lot of new changes going forward.
Okay, one other question has come in, and this one is about printing metals. Where is
Yes.
Objet on printing metals?
The good old printing metals question. You know, this between this and printing people and human organs, these are generally a lot of the standard questions, and that speaks to the successful growth of the industry at large as far as detail, speed, and just how successful we've been going into the rapid manufacturing world. So naturally, the fact that things have been so successful, the next progression that people want are metals. We're not there yet, otherwise it would be released, but you never know. Like I said, we're always releasing several new materials a year, so stay tuned. You never know what the future holds, including maybe printing people.
Yeah, at the moment, printing metals is a whole different process.
So I say that tongue in cheek, but I do like that vision of Chang.
Okay, that seems to be it for all the questions that we have right now. You can see on your screen, if you do have any more questions, you can contact Susan or Chang at their email addresses. And if you wish to email me, you can do so as well. So I'd like to, again, thank everyone for attending this webinar. And just a reminder, this will be emailed out to you in the next day or so, and it will also be available on the designworldonline.com website. Thank you again, everyone. Have a great day.